Okay, folks, we're going to get started. This is really impressive. I wasn't sure how many folks we'd see in the last hour of build.
Crazy. Thank you all for coming.
Yeah, thank you very much.
Yeah, seriously. Thank you.
It was awesome. We're going to get started. My name is Steve Herbst. I'm joined by my colleague,
Michael Medlock.
Michael Medlock. And we are psychologists at Microsoft, trained in experimental psychology, cognitive psychology, perceptual psychology. That's sort of our background. That's the area of training that we bring to the development of new solutions for Microsoft. So we work with our dev partners, our test partners, PM, design, to build solutions that work for human beings. And when you're building a solution, you guys know this, you need to know about the capabilities and limitations of the platform that you're working on, right? And human beings are part of that system. And just like a platform, they have capabilities and limitations with respect to sensing, input, output, processing, memory capacity. And if we don't understand those things really well, you can run into problems. You can get traps into your UI, and that's what we're going to talk about today. So I'm going to dive into this by telling a little story. We're actually going to get to the 3 traps that we promise in our title. But first, let me step back. Ask you to jump into a virtual time machine with me. We're going to go back a couple of years to the launch of Windows Phone 7. Remarkable UI, very new approach to UI that's been emulated in many designs, really influential, very well received. But as we'll point out, every UI has some traps. Right? The goal is not to eliminate every trap in a potential UI, and the case was no different for Windows Phone. It had at least one trap when it initially shipped, and that trap, I was warned about this, that trap had to do with the start functionality, which was enabled by the key that you see highlighted there.
Or the search functionality.
I'm sorry, thank you.
Yeah,
the search
no
functionality.
problem. I'm there for him.
Thank you.
He'll be there for me too, don't worry.
Yeah. The search functionality enabled by this key. And in a subsequent release, and I'm not going to talk about the details of that, we'll get into it within the next hour. It was addressed in a subsequent release of the product through the addition of a contextual search key. And that problem went away. Fast forward 1 year to the launch of the Xbox 360 dashboard update. This was the first application of our modern UI to Xbox, very well received by our customers. Like all UIs, as I pointed out, had some traps. One of them had to do with search, which is enabled by this control here. In a subsequent release, we addressed this with the addition of a contextual search option, and the problem went away. Fast forward 1 year to the release of Windows 7. Just a bold step by Microsoft to integrate our development platform across input devices and display types, device types. Like all UIs, has some traps. In this particular case, there was an issue with our search functionality.
See a pattern there?
It's enabled here. In a subsequent release, this was addressed with the inclusion of a contextual search option, and that problem went away. So, is there a pattern that folks recognize here? Okay, so kimono's wide open here, folks. We're prepared to give you some hard lessons learned, share them with you, and I'm confident you'll be able to benefit from these lessons. But I'd ask another question. Is this unique to Microsoft? And we can fairly confidently say, no, it is not. Whoops. No, it is not. You don't have to look too far. In any given month, if you just do a search on terms like usability, ease of use, product, review, et cetera, you'll see that our competitors are similarly challenged getting products out that people find easy to use, that meet their needs. What you will find is there's sort of a pattern. If the products don't fail as a result of these issues or other issues, they eventually fix these things, and they get better. And we're left with a question of, why does this happen? Why can't we address these things before they go out? Is UI just hard? Right? Human beings are complex. It's all subjective. What's good UI? You can't tell, consistency. Sometimes it's good, sometimes it's bad. Or is there some knowledge that we can apply, some rules that we can apply? Michael and I will assert that there is. In fact, there's over 100 years of research into what makes systems work or not work for people. The problem is the information isn't particularly accessible. It's very hard to remember. Some of it's counterintuitive. If anybody here was at a session yesterday by Amy Alberts, a fellow design researcher of ours, she showed the Wikipedia site for cognitive biases. It's very long. You can scroll through many pages. These are things that sort of blind spots that we have as humans because of those capabilities and limitations I made reference to before. So as developers, creators of things, we're susceptible to missing things in our own designs because we may not look at it as our users do. So we're going to try to highlight some of those. So over the past several years, Michael and I have been working to sort of rein in all that knowledge into a system that we can apply. So we developed something internally called tenets and traps. This is not rocket science. What we've done is we've created just sort of a set of categories. Tenets of good UI design. I'm going to walk through them. You're going to look at them and you're going to say, yep, that's obvious. Those are all good aspects of user interfaces. And we're going to talk about traps. These are things, the real workhorse of this tool. These are the things that you can detect in a UI that actually predict a degradation in a tenant. So if you can isolate those traps, you're going to improve your tenant compliance. You're going to improve the overall goodness of the UI. So this tool, in its essence, is designed to, very simply, help us detect traps, their presence, recognizing that all UIs have traps and you're going to have to make trade-offs, et cetera. We want to predict the consequences of those traps. What do we have to do about them? How serious are they? And then finally, obviously, we want to resolve these things. That's it. Pretty simple. So let me just introduce our tenants quickly. Imagine you're in a city you've not been in before, and you encounter a kiosk in a train station, and you have to use a ticketing kiosk. You have to use that. Our first tenant, very simply, if you approach that kiosk, oh, we're getting some weirdness in our system.
There we are.
So bear with that. That's unexpected. To the extent that you understand what's required of you when you hit that kiosk, we would say it's understandable. Let's say, for example, that you need to hit a control, a touch target. If that target is accessible, it's large enough, you're able to physically actuate it. We call it physically effortless. When the system comes back, it's perf. If it's appropriate, we call that responsive. And if all things being equal, the number of steps you need to take are minimized, we'd refer to that as efficient. And if through no fault of the design of the system, you make an error, does the system allow you to recover? The system's forgiving if it does that. Recognizing that you're in a social context, right? You're in a public space if you're using a kiosk. You want a system that's discreet, that doesn't, for example, doesn't put your credit card information up there for everybody to see. We also, if you're using a credit card, don't want the data to get wiped. We don't want data loss. That's a very important tenet of good UI design. Next one's interesting, and it's one we're going to talk about today. You've now got a system that's pretty good. You can go in there and you can use this, use your credit card information to secure a ticket. Everything works pretty well. But what about the next day when you come back and the day after that? Does it become automatic for you? There's a distinction between something being understandable that you can grok and figure out and something actually becoming almost unconscious. So we want systems that are habituating, that are habit forming. And we're going to talk specifically about a trap today that contributes to that. Finally, boy, that seems like a pretty complete system, right? Well, what if the train station just looks better as a consequence of this thing being there? Or there's some whimsical component to the interaction that allows you to enjoy all these tenets, but it's just fun. For that, we have a tenet as well, which we call beautiful, sort of the compellingness of the design. So these are our 9 tenets, fairly obvious, right? If you've ever used you've seen a user use one of your applications or been the user, as we all are, of products, you can probably characterize any problem you've ever had as sort of a violation of one of these things. So as I mentioned before, the workhorse of this tool is a set of 23 traps that are nested within these tenets. And we're going to focus on a subset of these today. Understandable. Habituating. And they're all over the screen. This is bad. And in fact, we're going to focus on a subset of those. 3. We promised 3 traps. Why these 3? These 3 traps are very frequently occurring. And they have that characteristic I described before. They lend themselves to being missed by somebody working on a product. It's very easy when evaluating your own solutions to miss these because sort of the curse of knowledge. You understand how things work. So with that, I'm going to hand things over to Michael, and he's going to tell us about our understandable traps.
All right. So before we do, got a little exercise, a little group audience participation. Yeah, I'm going to focus on these. What does this word mean? This word is used a lot to describe what good user interface is, intuitive. And Steve's going to have to jump off the stage here pretty quick because he's going to be my person in the audience a little bit. We like people who sit in the front row. You, sir, in the green shirt, what does this word mean? And I'll repeat it.
The user knows what to do without having to be told what to do.
The user knows what to do without having to be told what to do. Thank you very much. You get a headset for that. We like people who participate. Great answer. Right, you, and yeah. What does it mean to you? Easy to understand, easy to pick up without too much information. Another great answer. I think you get candy because, we're running out of headsets. Sorry. Someone else will get a headset. Someone else will get a headset for something. First volunteer gets the headset and volunteer. Good. Thank you. A couple good answers. I'm sure many of you are thinking something sort of similar. This is the dictionary definition of this word. A couple key things I'd like you to focus on are the words without conscious reasoning and instinctive. Without conscious reasoning and instinctive. And with that, everybody stand up. I'm not kidding. Everybody stand up. Let's go. Devices down. Everybody stand up. This doesn't work if everybody doesn't stand up.
To it. You want to get close to it?
Okay. We are all about to be the users of a brand new interface right here today. Okay? It's revolutionary. The way this interface works is you have to use your hand and your arm in order to operate this interface. What I'm going to do is I'm going to show you a before picture. In fact, I'll show you the before picture right now. Here it is. Here's the before picture. So you got to be looking at the screen in order to do this. And what I'm going to do is I'm going to count to 3. I'm going to say 1, 2, 3, and then I'm going to show you an after picture. When I show you the after picture, what I want all of you to do without conscious reasoning, instinctively, quickly, is to make that before picture into that after picture. All right, you all ready? Okay, here we go. Ready? 1, 2, 3. Awesome. Stay standing. I'm going to do it again. Here comes the second picture, all right? Here's the before picture. Remember, don't stop to think. Just do it. Do it fast. Ready? 1, 2, 3. All right. One more time, everyone. Okay, here's the before picture, and here's the after picture. Again, don't think, just do. Ready? 1, 2, 3. All right, thank you very much. Give yourselves a round of applause for participating. You have actually just participated in an actual, version of an actual research study that was done out of Microsoft Research. It was done on touch. It wasn't done with hands and arms. But the point is still the same. It was done by Andy Wilson and a number of other folks. Great stuff. So what is the point? What is the point? Remember that word intuitive? There's no such thing. There's no such thing. There are only things that are learned and not yet learned. See? Learned and not yet learned. Intuitive. So why, especially for the folks in back, I bet they all saw this, for that very first one, right? Like everybody seemed to do about the same thing. The next two, everybody's all over the place. So why did everybody do something pretty darn similar that first time? Isn't that instinctive and intuitive, Mike? No. When we were all little before the age of 1, every single last one of us, as babies, learned to grab and move physical objects. And we had to learn that. We were not born with that. Anybody here with children? Anybody here? Yep, great. Yep, I have children too. I bet you remember that. It was a momentous, occasion when your child reached out and actually purposely grabbed something. And we spent the rest of our lives learning how to grab and move things in physical space. Nobody sat around and learned how to copy things in the real world or change their color in the real world. These are magical things that we do with user interfaces, that you do with your user interfaces that you develop. So what's the point of all this? Every new thing has to be learned. And learning isn't bad, but you can sure make a mess of it. So let's talk about a couple things that can make a bit of a mess of it. And one of them's pretty obvious, and the other is so not obvious. So let's start with the obvious one that we can all laugh at us and so forth. This is a defunct product. Now, this is the Palm Pre. And the Palm Pre had many, many things going for it. And believe it or not, a lot of people emulated a lot of things that they did. What I need to have happen now is everybody who has not used the Palm Pre in the past or knows anything about it really to stand up. Don't be shy. Everybody who has not used it in the past, stand up. Great. We got tons of people. Excellent. So let's imagine with the Palm Pre, it's a smartphone, it's a touch smartphone, that you drilled in a couple levels into this thing. Come on, into the Photos interface. And you went in a couple levels. You didn't just go one into the Photos. You went like a couple folders in, etc. And now you've decided that you want to get back, not to home, back one level. You, sir, in the Packers, how would you get back? Don't think, just say it. Push the button. A good answer. You get some candy, but no. That's good. That's good. Striped shirt over here. How would you get back? On where about?
Just swipe
Left in the middle of the screen or something like that. Swipe left. That's a very reasonable answer, and it's not accurate. Sorry. So the way that you'd have to, very close though, very close. So the way that you'd have to do it is you would have to swipe this direction in that area. Right there, in that area, all right? You can sit down now, thank you very much. So what do we call that? That is our first trap. That is an invisible element. I was told something once by somebody, and I kind of like it, and that is, humans have a difficult time discovering invisible things. Are we immune to this? No. But are we learning? Yes, we're learning. Yes, Windows 8, here we are, the charms. Here they are. Steve already gave us this example. There's search amongst other things. Sorry, the little highlight's a little bit off there. Yes, this is an invisible element, but we're starting to fix those, as Terry pointed out in his announcement. This is not the only one of these that we've got going. That we're starting to fix, right? Don't do this. The funny thing about this is that invisible elements are interesting because for power user features like shortcuts, or other things, that's fine. But for things critical to the functioning of the system, danger there. Be careful. That's, I guess, what I'll leave. And I don't know if he'll add anything later. He might. All right, let's go into the not so obvious one. That one's pretty obvious, right? Duh. Invisible things. Ha ha. Everybody take your hand, stick it straight out in front of you, and look at your thumbnail. Look at it. What you are looking at is what you can actually see in fine detail. That is just where your fovea, you can put them down now. That's where your fovea focuses. And what happens is we move our eyes around super fast, and then our brain constructs the reality, that we see. And the rest is very blurry, but we don't see that because our brain constructs that for us. But we move that thing around super fast. And so that's a constraint of our visual system. But there's another constraint that we have, and that is our attention is limited. Some people say, I'm multitasking. No, you're not. What you're doing is you're moving your eyes and your attention very fast. But you're not splitting it. Don't believe me? All right. Let's watch a video.
I recognize that guy.
I recognize that guy. He needs to lose some weight. I am willing to bet, I'm sure many of the people in this audience have already seen a version of this video, but I'm willing to bet that there's no one, or almost no one in the audience, that knew the number of passes, saw the gorilla, did all these things, saw the black player leave and come back, saw the ball color change. I bet there's nobody who did that. Why? Constraints on our visual system, constraints on our attentional system, and also, one more little thing. All these things are mediated by our expectations. So if you came in and you didn't know about the gorilla, and some of you, it sounds like some people laughed, so maybe they missed it. They didn't expect to see a gorilla, so they didn't see it. They were attending to the ball. Some people who've seen a video like this, they expected to see the gorilla, so they couldn't stop themselves from seeing the gorilla. Let me repeat that. They couldn't stop themselves from seeing the gorilla. You're developers. You know the stuff you develop intimately. You cannot stop seeing the gorilla. It's impossible. By the way, when I get close to an interface, I can't either. I'm not special, in that way. And this is the heart of our next track. Whoops, there it is. The effectively invisible element. That gorilla was right in front of your face, and some of you didn't see it. That ball changing color was right in front of your face, and some of you didn't see it. This happens. It's all about expectation, vision, and attention. Let's look at the synapse. Here's a little game app that we made. I'm in games, by the way. That's what I do. I do user research on games. There's Flowers. You download it. It's a cool little match 3 kind of game. And the way this game is played is that you try to match 3 things. So in other words, you try to, here, if this thing will work, you try to put down flowers, and when you match 3 flowers, then those clear, yay, you score some points. And what you try to avoid is this situation where you filled up your entire board and you can't go on any longer and you lose. All right. So the initial design, well, first, what that means is it's very, very, very important that you know what the next flower is, right? Very important. So the initial design of this thing looked like this. And it looked like this because the designers really wanted the next flower to be very salient. They wanted that next flower to pop. And that next flower was this one right here. And then the rest of the flowers that would follow that flower were these right here. Unfortunately, because of the nature of vision and attention and expectations, things went awry when people tried to use this design. And that is, it's difficult to attend to both those things at the same time. So what would end up happening, and yes, that's an effectively invisible element when that happens, what ended up happening is that when people attended to this one, no worries. They knew what was coming next. It was a yellow flower. But when people instead would attend to this one, they would expect a blue flower, right? And so where would they put their blue flower? They're trying to match 3. They'd put it here. Except they wouldn't get a blue flower. They'd get a yellow flower, and they'd be mad. So it's funny, the solution's really simple. This is the solution. They solved it. Nice, effectively invisible element goes away. These occur in other situations. Here's back to the thing that Steve talked about, Xbox One. Or no, sorry, not Xbox One, Xbox 360. This is kind of a pixelated view on purpose because it shows you what the user is looking at, like when you do eye tracking kinds of studies. This is where people expect to look to find things. So if they form the goal to search for something, this is where they'll go looking. But unfortunately, that is not where the thing is, if this will work. Come on, baby. There it is. That's where it is. And they don't look there, so they don't find it. That's an effectively invisible element. And again, that went away because we brought it up into the place where people expect to find the thing. Finally, Xbox One, we did a ton of work on voice, complex system, and people have to, back to learning, they have to learn something about the vocabulary. There's no way around it. One of the most important vocabulary terms was the term select. This is an old initial kind of design that was going on, and they felt it was so important that they were going to put it up top and in the middle. And unfortunately, that meant everybody missed it, because that is not where people expect to find it. That's not where people are expecting to look. They're expecting to look down where all the other things are. And so, okay, well, we're going to make it, pop, with a different color, and we're going to get it closer. Nope, also not. That is not where people expect to find it. Where did they expect to find it? They expected to find it with all the other things, right there. And so when it was put there, that is when that went away. So I'm handing off to Steve here, but before I do, a key thing to know about these two traps, and we don't have time to go over everything, just showing you a couple things, is you have to know something about your user. Again, you can't stop seeing the gorilla. So you have to know something about your user, where they're expecting to view things, where they're expecting things to be. That's it.
Well done. Yeah, so the only, thank you, Michael. The one point that I'd make that Michael didn't hit on there at the end was the catch on Xbox One with the select function was done prior to ship.
That's right.
So by establishing internally our understanding of this as an issue, sort of creating a little package around the idea, the generalized principle behind it, we were much more sensitive to it as an organization and could address it. And so that's what we're hoping you get out of what we share here today, that you can sort of generalize this knowledge and become a better detector of these things. We're going to go on to our next topic. And for this, I'm going to ask everyone to stand up. Okay, we're going to play a very quick game. We just didn't want you to fall asleep because it's late, it's the afternoon. We're going to play a quick game of Simon Says. Okay? Everybody remembers how to play that, I think. Very quick, and then we'll be sitting back down. So just follow along. Simon says, put your hands at your side. Simon says, put your hands on your shoulders. Simon says, clap your hands. Cross your arms. Pretty good. Some got it. Simon says, cross your arms. Simon says, put your hands on your hips. Simon says, put your hands on your sides. Now, the next one's tricky. Next one, after I'm done, if you've done this correctly, Simon says you can sit down. Okay, and so Michael's going to watch. After you're done, Simon says after you're done, you can sit down. And Michael's going to watch for honesty here. Okay. Simon says, cross your arms the opposite way you normally do, and then sit down. Honesty will be rewarded. Oh, we don't have that many headsets. Come on.
You got to sit down. Sooner or later, you're going to do it, right?
Cross your arms.
Cross your arms the opposite
Simon
way,
says, cross
and once
your
you've
arms
done
the
it, sit
opposite
down.
way, and then sit down. And that's all Simon ordering you to do that.
So you haven't crossed your arms? Yeah.
Okay. Pick somebody.
I'm going to pick somebody. I'm going to wander out there. Thank you. Give yourselves a round of applause.
Quick question. I asked you to, Simon told you to cross your hands initially and then asked you to do it the opposite way. Do people have to think a little harder the second time?
Welcome.
Okay, a little bit harder. Okay. One of those things was habitual, right? One of those things was something that you've done many times in your life, and it required no conscious thought, no application of sort of your cognitive resources. The other took a little bit of time, right? So what we're going to be talking about now is habituation. Really important topic. It's that distinction. How do you get something to happen? I mean, you guys can understand what I said. Did anybody question sort of what I was instructing you to do? No, but your ability to execute it quickly and mindlessly was challenged. So I'm going to do one more thing before we get into our traps, and we're going to do a little thought experiment here. I'm going to have you jump back into that virtual time machine. We're going to go back many years at this point. Okay? I want you to think about your first experience driving a car, learning to drive a car. Okay? Close your eyes. Take yourself back there. Perhaps you're in a parking lot. You've driven to a parking lot with a parent, an older sibling, or you're on a quiet road where you're going to start to learn to drive. You're in the passenger seat. The adult driver is in the driver's seat. You stop. You get out of the car and you switch seats and you get in for the first time. And you're getting instructions on changing your mirrors, adjusting them, adjusting your seat, getting comfortable, fastening your seat belt. You're a little bit nervous. You feel the wheel turn, you feel the rubber on the road. That's a little unusual. You know, you're sort of getting you're pounding the brake and the accelerator, sort of getting the feel for that. You're hearing the sound, and maybe your foot slips off, and you actually have to crane down and look under the dashboard to see where the ends of the pedals are, because maybe your foot slips off, and you just want to be confident you really have those things. And then it's actually time to turn the ignition and start. And maybe you just turned a little too far, okay? And you grab the shifter and you put it in. You're going to put it into drive, and maybe you overshoot. You go to D2 and you adjust it back, and it settles in. Now it's time to go. Maybe you hit the gas a little too hard the first time, hit the brake, oh, you hit the seatbelt, your driver says, it's okay, you're doing fine. All right, minutes, hours, days, weeks, months pass. Eventually you have your license. You're still learning, but you're getting better. And now flash forward today, and you can open your eyes. Think of the last time you drove a car. Might have been this morning, might have been recently, in the past week or so. How many folks here remember how many times they hit the brake? How many folks here remember hitting the brake? Unless you had a critical incident, like really remember it. Okay.
Here, raise it high if you remember hitting the brake.
Yeah, there's no.
It's no shame, and there's nothing wrong with it.
It's more likely on
I
a
hope
given
people
day.
hit their brakes sometimes.
It's more likely, yeah, hopefully somebody. It's more likely that what you might remember from your most recent drive is a story you heard on the radio, and you can put your hand down. A story you heard on the radio, a conversation you had in the car, maybe a phone call. Maybe you don't even remember. I don't even remember driving to work, right? So this is fantastic, right? This is an incredible transformation. You went from this situation where all your you remember that, right? You remember that feeling. All your cognitive energy was focused on this. Imagine if when you were learning, the person you were with gave you a complex mathematical problem to solve while you were trying to learn the car. That would probably be tough, right? Do you think you could do that in a car now if you wanted to and continue to drive and focus, tackle a problem? Probably do it all the time, right? So this is, what's going on here? How do we exploit this? How do we get the answer? Fortunately, we live in a time where there's an individual who is absolutely brilliant at cutting through issues like this. I feel privileged to live in this time for that reason, because we can really rely on him to get clarity on these things. If we can understand this better, we can exploit it. You all know who I'm talking about, right? Stephen Colbert. Yeah. So Stephen Colbert had a guest on the show not too long ago, a guy named Steven Pinker. He's the head of psychology at Harvard University. He's written notable books such as The Language Instinct, How the Mind Works. So he sat down as a guest on Colbert's show, and Colbert looked at him, he said, you study the brain, complicated topic, right? Really, really challenging stuff. So how does the brain work? 5 words or less. Steven Pinker rose to the challenge, rolled his eyes. Brain cells fire in patterns, and the crowd went wild. So once again, Stephen Colbert cuts through all the noise, gets to the heart of a very complex issue, makes it very simple for us. And in fact, this simple idea is really powerful, what Pinker captured there. Brain cells fire in patterns, and for the purposes of the section we're going to go into, there's just a couple of words I'd add. Brain cells fire in patterns, fire the same pattern repeatedly and consistently, and things become automatic. Duh, right? Sounds like practice, right? Practice makes perfect. This isn't mind-blowing, but it's true. Right? There's a physiological change that takes place in your brain as you go from learning something initially to mastering it. How do we exploit that in our systems? How do we get people to that state? That's in our interest, right? We want people transacting in our apps. We want people having fun in our apps. We want people engaging and returning. We don't want them thinking about the systems they're using. We want it to become automated. So are there things we can do? So I'm going to show you some examples, but first I'm going to just take you back in that time machine to that first driving experience again. I'm going to have you think. I'm going to ask you another thought question here, thought experiment. If the vehicle, for reasons I won't attempt to explain, was designed such that the brake and the accelerator changed function periodically. Let's say when you're going north-south, it's the normal way. When you're going east-west, it's the opposite, okay? So you can let's stick with 2 this time. So you've got a compass on the dashboard, so you can monitor that and understand what state the system's in. And you know what? We're going to put a light there next to it too, just to reinforce when it goes into the reverse mode. There's going to be a light.
The light will do it.
Yeah. Would it take you less time or more time to learn and master that vehicle to achieve the level of proficiency you have today? More time. Yeah, most people agree more time. And you never see anything like this in a UI, right? Right? Why does it, and we're going to look at examples, you will, obviously. Why? Why does this happen? Well, this is a perfect, I talked about some of these, some of our understanding about human capabilities and limitations is counterintuitive or just sort of hard to grasp. This is one of those. This is an issue of consistency. And as folks know, sometimes consistency can be good, and sometimes it could be bad. So if we were to say to you, oh, we're the design research guys, we've got some recommendations, you always need to use the same font and the same font size, because we've learned that there's a particularly readable font size. And your background should be a particular color, because there's an optimal thing. Those would all be rules of consistency, right? You could apply that in an in-vehicle context as well, right? You could say all interiors have to be black, and Henry Ford said it once, right? You can have any color you want as long as it's black. Everybody would agree that's probably foolish consistency, but there are examples of consistency that we want to follow so we don't have our users fall into traps. So how many folks remember how mobile phones used to work? They had send and end keys. You remember that? These two keys? Okay. And these were interesting. These allowed you to, obviously the send key would allow you to make a call. The end key was interesting. It functioned as a power key. There's a little power symbol there. You press and hold it, and it would power up the phone. It functioned as a home key. So as you navigated into the UI, you could hit the home key and you could go back out to the top, which makes perfect sense, right? So they're building the first phones with increasingly sophisticated UIs. Why add another key? And I'm done with what I'm doing. I've ended. I'm going to go home. That makes perfect sense. It's efficient. You don't have to add a button. And we shouldn't forget, it also ends the call, right? It's called the end key. Little problem emerged in those early designs. What happens when I'm on a call, particularly as the UIs got more sophisticated? I'm on a call, someone asks for information, I dive down into my UI, get that information, and they ask for another piece of information that requires me to navigate in the UI. And I habitually go and hit that key that functions as my home key. And what do? I end the call. And then so the follow-up to that was some really kludgy things, where you had to hit the key twice, right? Or you had to press and hold the key, which, by the way, if you pressed it and held it too long, would power the phone off. Classic example of what we call a variable outcome. Same user action, different result. And there's going to be one caveat I add to this, because we're going to see that in certain cases, you can allow the user to do the same action with a different result, and that's okay. And I can explain that. So we showed an example at the start of our presentation. Bear with me with this. This was the example of where the search key, and in this case, the original 7 design, if folks recall, this key went to the Bing search page, as it does now. Unless you were in an application, first-party application, with contextual search, then it searched contextually. Okay? So as a user, if I am in a first-party app with contextual search, and I'm using my phone, and Michael interrupts me, he says, oh, Steve, I need that piece of information. Can you go look up, and I use Bing, and my attention, this isn't strictly about where you put that fovea. My attention is on the goal of, oh, I got to search for that, Bing, because I've habituated to that action, just like I habituate to hitting a brake. And it searches contextually, and I'm disoriented, and I don't like it. Alternatively, I could say, oh, this has contextual search, it's great, but I could be in a third-party app. Am I attending to whether it's a first-party or third-party app? No. And so I hit it, and it goes to a Bing page, and I'm confused. So same user action, different result, and that constitutes a variable outcome. And that was addressed, and we've seen this across our other products, by the introduction of a distinct contextual search key. You've got a brake that brakes, you've got an accelerator that accelerators, the two shall never meet, and you are able to habituate. That is able to become automatic. You can use those things without engaging brain. There's a physiological change in your brain. Brain cells fire in patterns, fire the same pattern repeatedly and consistently, and things become automatic, and now you're free to think about the goal that you have at hand. So this is a really, really important concept. And it lends itself to assessment in your code. So you can test for a variable outcome trap. I've got a user action. And I ask myself the first question. Is the response consistent across device states? Okay? And if it is, well, obviously, if the brake is always the brake is always the brake, this is not a candidate for a variable outcome trap. Good, you're good. No worries. There's a second question, though. And that has to do with user attention, and it comes back to the topic Michael talked about before. We have very limited attention. Not only is our high-resolution foveal area small, but even when something falls on our fovea, if we're not expecting it, we can miss it. All right, so we ask ourselves this second question, and in this particular case, if I'm attending to it, and I'll show an example in a moment, I don't have a problem. But here we actually have the case where I'm not attending to the state. It can go to 2 places. I've got a problem. So that's a variable outcome. So I'll just talk about the slight nuance here and how you can think about it. if you think about just the home screen, your live tiles, or just your touch screen on your device, same user action, I'm touching the same piece of real estate on that screen across different states, I get very different results. It might be my SIP, it might be another tile as I scroll. No problem for the user. Why? Because their goal is perfectly aligned with the action they're taking. So when I'm driving the car, my attention is through the windshield. It's not on this indicator on the dashboard. But in this particular case, my goal is to find my IE icon at this point, and it's perfectly aligned, and I have no problem. So when we apply our question, does this operate consistently? No, it does not. But is my attention on it? Yes, it is. There is no trouble. So we can see this manifest in other places. And I'm going to take a moment to say one thing, because we are being very candid in what we're sharing here today. We do this internally as a 4-hour course for folks, and we use lots of competitive examples because we're able to do that internally. So we're showing you lots of Microsoft examples, and I'm going to show you one right here. But you will see this in all sorts of contexts. And this is going to be one that's familiar to folks. Associations in Windows 7. Right? So I've habituated to the idea if I can click on an attachment, for example, and it's going to launch the associated application. I'm not attending to the inherent implication of that action when it's associated with the modern shell and the fact that I'm actually going to change effectively the operating system of the phone along with launching that application. That's a problem. And that constitutes a variable outcome. And with Terry's announcements early in this week, we can see that windowing of these applications eliminates that problem. Right? So the user's able to habituate to actions. I'm in the desktop mode, I see an association, I launch it, and there's no loaded change in behavior that's going to occur. We have other examples of this. Right-click for contextual menu. I've learned that behavior, I've habituated to that right-click, just like my brake. That right-click on the mouse over an object produces a result, it's very predictable. I'm not stopping to think about the UI. I'm just carrying on my action. Really, really desirable thing. So that one goes away. And then we can look at an example, and this is actually from Michael's domain. Skulls of the Shogun, great game for Microsoft Studios.
Cross-platform?
Cross-platform, yeah. So you can play this on your Windows Phone devices. You can play it on Xbox. And this is actually a great example. You might have noticed there's a sort of a hardware thread that goes through here. Variable outcomes aren't strictly a hardware-related issue, but they often emerge where you have controls assigned. And there's this temptation, very often controls are limited, there's this temptation to sort of overload those controls to get as much functionality as you can. So there's a real good lesson here. So in this particular game, you position you have the ability to pick one of several units or characters. So you use your arrow keys to be able to do that. And then you can come over and with A, you can select a particular character. So let's imagine you pick the unit there in the bottom right. And once focus is on that character, the A, B, X, Y buttons allow you to do different things with that character. Here was the mapping as the game developers originally created it, and Michael discovered it. Michael did something with his team called a trap analysis. We do lots of these. And what trap analyses allow us to do is apply systematically this knowledge to see if we can uncover these problems in our UIs. It doesn't require user testing. I'm not saying we shouldn't get stuff in front of users. In fact, it's very important, and you do it whenever you can. But there's actually a value in being able to look for these things, and you can do this yourselves. What Michael discovered was there's a hold position function and a cancel last move function on that. And it's basically, if my position is held, I cancel. Otherwise, I hold position. The problem is the user needs access to both of those actions concurrently. And the only way for them to know what action is going to occur is for them to attend to, and I'll show it momentarily, a key that's on the screen that tells them what that action is. Basically, they've got to look at the dashboard, at the compass, or that little indicator light before they hit the brake and the gas pedal. Very disruptive to the game. You do not want that. And this was an interesting one where these guys really had to tackle this problem. They knew something was wrong, but they couldn't quite isolate it. This was the dynamic underneath. So having completed that trap analysis, and I'll just point out, you can apply the sort of the logical analysis that I showed before, and you can see that, in fact, this constitutes an instance of a variable outcome. So the prior design was this. Michael, working with the team, did something that you would expect at this point and simply disambiguated that functionality. Right? So there was a secondary and tertiary control. The tertiary got relegated to another control, on the control, a bumper or something.
Something like that.
So those two important controls now had their own things, and people could habituate to the action. The brake was the brake, the accelerator was the accelerator. The two never met, and the user could focus on fun, right? Not this control of the system. And this is another example, and there you can actually see the end result. This is how it is in the game. So the cancel is on the B control, and the wait here is on the A control. Previously, this was the dashboard light compass that the user had to attend to if they were going to play the game effectively. It was fixed. Again, this one was caught before we went out with the product. And so this is how we're operating. This is a tool that we're using. And again, it's something you all can benefit from. And we hope, if you have any questions about these, you'll see us, because we want you to be able to develop applications that don't frustrate folks, but keep them focused on their goal. And that's that. And just a final note here, and I've already touched on this. Michael talked about knowing your user. You need to know your user for a variable outcome trap, but there's really an interesting takeaway here. It's the idea of know your code. Look for those state handlers. What you have to know about the user is where their attention's likely to be, but often you're able to sort of tease that out without necessarily putting it in front of a user, because you know what the focus of the UI is. You can ask yourself these questions, and you can avoid the types of examples that I've shared with you. And with that,
Well, tell them this, we got some time. Tell them the Larry Tesler story.
tell them about Larry. So folks here know Larry Tesler, originally at Park, subsequently at Apple. He's been at Amazon, a few other places. Larry was, for anybody who doesn't know, Larry is the guy who gave the demo to Steve Jobs at Park for the GUI, before Steve hired Larry and put him to work at Apple, what ultimately became Apple's sort of legacy UI, OS 10. I had an opportunity to have dinner with Larry, and I asked the question, because I'm inspired by his work. Larry has a license plate, if folks aren't familiar, that says no modes. Right? And he's had it for the past 30 years, still has it. And it was really my early reading on Larry's work where he identified this modal problem that sort of inspired me to try to make it more understandable to folks. Because as a researcher, I would spend a lot of time with users seeing these kinds of problems, and I'd try to explain it back to folks. People would say, oh, no, they can figure it out. They'll look, they'll see, they just have to look over here. I know how it works. Again, so sort of that curse of knowledge that we have when we're intimate with our systems. And so I just said to Larry, what do you recommend? How do you teach this concept internally? And he said, I just tell people to look at their code. Right? And I'll give you a bonus one. We said 3 traps. I'll give you a bonus one. That is, we have another trap we call gratuitous redundancy. And gratuitous redundancy just speaks to having the ability to go from one place to another in the UI. I'm sorry, I should say having 2 ways to go from one place to another, 2 or more ways. This is rampant. I could go through, if we had more time, I could show you 15 examples of these existing in modern websites, in applications, in any number of content, in airport signage designs, where the user is encounters a couple of places. And these are very easy to look for in code. This is another example of a habituation trap. When a user is confronted with a decision point, it takes time. They have to think about it. And remember, brain cells fire in patterns, fire the same pattern repeatedly, consistently, and things become automatic. If you're giving users choices of 2 ways to do things, it'll cause problems. And in fact, there's often a really good, the best intent with these habituation traps, variable outcome and gratuitous redundancy, where you are thinking about the user. You want to add that extra functionality, so you overlay it on another control because you want to make it available. Or in the case of gratuitous redundancy, well, they may be looking over here. So I'm going to put the control here and here.
Yeah, just put it everywhere, right? Just put it everywhere.
Yeah, user may be there.
All
What
over
you
the
end
place.
up doing is diluting their ability to encode that neural pattern that you want that frees up their sort of neocortex to focus on their goal at hand. So those are 2 examples where you can look at the code, and you can look at references from one location to another location in the code and see that. And that's an alert. There will be exceptions. Not every trap is severe. There are reasons to trade these things off. But you have 2 really good indications of things to look for.
And have a good conversation about it.
And have a, really important point, as Michael will say, that these things are the beginning of a conversation, not the end, are traps. So as we introduce one of these things, we say, what do we know about it? What do we think the consequences are? If we change it, do we introduce any other traps? So I will turn things over
Yeah, sure.
to you at this point.
And I'll babble some more, I guess. All right, so coming a little to the close, and because we have a little more time, do you want? We'll do that later. All right. A little recap. So we covered 3 traps, and then Steve gave you one more. And, got invisible element, effectively invisible element, variable outcome. In a word, general, it's probably better to make critical things visible, not invisible. Start gaining some information about where your users expect to see the actions that you are putting in to your applications or to the things that you make. This is the place where you do have to know something about the user, and that we certainly do too. Like Steve said, we can detect some of these things a priori without users, but for this one, you need to know something about your
and I'll just
user.
offer one thing there.
Yeah.
I talked about seeing things in code, not needing users necessarily in some cases. These are traps where you would want to put something in front of a user, and the real key there when you do it is to give them the abstracted goal.
Yeah.
And get
Don't
out of the
tell
way.
them exactly what to do.
Get out of the way and watch them. And you guys, I mean, you know this stuff. You're not going to say, go to this place and try this thing and tell me what you think about it. You're going to give them the real high-level goal.
And watch
Observe.
'em.
And if you're sensitive to this, you may see somebody struggling. And otherwise, it's one of the reasons we built this taxonomy. There could be any number of things causing the user to struggle.
Yeah.
They don't notice it. They notice it and they don't understand it. Right? Are 2 like perfect examples. So good area to get user input.
And then, again, for variable outcome, beware controls that change global actions based on modes. Really look at your global actions. And kind of an overarching thing, remember, we can't stop seeing the gorilla. Okay? We can't. It's impossible. So detection, prediction, resolution, that's what we hope this little bit of this system that we've taught you tells you something about. Hey, you know, we have 8 minutes.
We can take questions.
We can, or we can do a skit.
Sure. Let's do
Yeah,
skit. You want one
Steve-
more trap?
Want one more trap?
Or do you want questions?
Traps,
Traps.
awesome, traps. All right, so you and I are going to do the skit,
Oh,
right? Because they can hear us and they can
Okay.
speak. So come out here.
2-act play.
Yeah, 2-act play. 2 acts. 2 acts to this play.
So first act, curtain. This is a short play.
Do I start? I'm going to start. Okay.
Curtain rises.
Hi.
Hey, Mike.
How's it going?
Going great.
Great.
Curtain down. You can applaud if you want.
Yeah. Because that was
Big.
just awesome.
We usually get volunteers for this.
Yeah, but you don't have mics, so we'll just make fools of ourselves. All right. Act 2.
Curtain up.
Hey,
Hey, Mike.
how's it going?
It's going great.
Cool.
And curtain. You can clap.
Yeah, you can clap. Even though we're terrible actors. You, ma'am. How did Steve feel? How was he feeling his character the second time? He was feeling indifferent. In the green shirt. Yes, you. How was Steve feeling the second time to you when you watched it? Upset? Cool. Upset, indifferent. In fact, there was only one difference between the first act and the second act. The latency. That's right. What we did is we added a second. 1 second to the interaction, because it turns out that perceptually, humans are rather hardwired in order to detect latencies in conversations. Perf, right? Good old perf.
Yeah, this is work that was done by the recently, sadly deceased Stuart Card at Stanford University.
Yeah.
So you just participated in a study, in fact. You've participated in a couple, whether you knew it or not today. He actually would have participants come into the lab in Palo Alto and listen to, in another room, Confederates having conversations where their utterances were manipulated. And they zeroed it in. It's really a predictable 1 second lag. So when people are using your systems, if there's a 1 second lag in a conversational interaction with the system, they will start to attribute to it human characteristics of it's ignorant, it's pissed, it's stupid, it doesn't like me.
Yeah.
In fact, this is a human time constant.
Yeah.
And there's lots of them. Many of you are probably familiar with like a 60 to 100 millisecond response time necessary for an animation. So it's a sort of stimulus response action. That's hardwired. That's based on sort of the electrical circuitry of our brain, how long it takes something to complete. There are a number of these. If anybody's interested, there's actually an author within Microsoft, a colleague of ours, who wrote a book. It's basically the psychology of interface design. Engineering Time is the title, by a guy named Steve Seow. Great resource.
Yeah.
And any number of these constants that you can apply so you can set some thresholds for yourself on perfect.
And probably the even more interesting one, besides the hardwire ones, are the perceptual ones. The perceptual ones. In other words, the ones where perceptual contexts that change things. Disney manipulates these all the time when you're waiting in line for rides. You can manipulate these all the time. We don't have it here, but one of the things that we often show audiences like this, and oh, by the way, the trap is non-responsive. Non-responsive. What we'll do is we'll show two progress bars animating, and of course, the joke is that they're identical in time, but one feels like way faster than the other, and the only reason is that in the beginning of one, things go slow and then they speed up. And then on the other one, things go fast at the beginning and then they slow down. Which one do you think feels faster? Accelerates at the end. That's right, the ones that accelerate at the end. And there's all kinds of these that Steve Seow covers in his book, etc. All right, that is it. 3 minutes. Questions? Thanks. Come on up to the mic. And I think are we the last session?
Yeah.
So, yeah, we're the last session. So thank you for coming to Build.
You.
If nobody else is, thank you very much for being here. Give yourself a round of applause.
Yeah.
Okay.
Yes.
Yeah, I have a question, and I'm not sure whether I want to ask this. I think I may be falling into a trap, or worse, being just irritating. But you're a psychologist, so I assume that everything you've shown us was intentional.
Maybe.
We're
going to find out.
There was a typo in the gorilla video.
Oh, that was my fault.
No, just a legitimate error.
No,
no psychology in that. No
there's
trap.
No psychology. That is, the psychology is Michael Medlock is a terrible speller.
Okay, that's fine.
And you know what you get? I'm coming
For
down there
helping us
for
improve
helping
the
me,
presentation.
so that the next time I do that, I do not misspell. What do you have?
Is there somebody over here? Yeah.
Just wondering, are you guys going to provide all the traps?
Yeah.
Is that from the slides?
We're working
or?
on that. This is actually our first public sharing of this. It's Microsoft intellectual property, so we're figuring out how to make it available to you.
Thank you.
Sorry, I'm talking over him. I'm helping him find the book that I just talked.
If we're people who either see the gorilla or don't see the gorilla, perhaps the perception is we as developers, we don't get it, we're dumb.
Yeah.
All right, and perhaps we report to
not
managers
dumb.
and to users and to clients.
Yeah.
How is it that we can explain and find a path through this particular perception?
Yeah, and want to be clear, the gorilla video has nothing to do with developers. It's human beings and the way we're wired. When you're given an instruction to follow a basketball, there's actually, the science is actually pretty interesting here. You've got top-down and bottom-up processing in your brain. So when you form a goal, your brain selectively, in that particular case, you have receptors for orange, for round, for moving things. And so when your goal is to follow the basketball, your brain actively suppresses signals that aren't round, orange, and moving. Actively suppresses it. It's been said that your brain does not care about reality. It cares about survival. So there's this construction in our head. So I want to be super clear. This is not a developer thing. It's for anyone who gets intimate with a system. So if I made that video or somebody deconstructed it for me, I can never look at it the same again. I've been sensitized to it. But when I have a goal, and this is really the takeaway with your users, they are going to approach your product with a goal in mind. We talk about this internally all the time. You cannot do a crit of a design with it projected on, and this sometimes happens, with projected on a wall in a room where everybody's going, what do we think about how the UI works? That is not how a user sees it. A user comes at it with a goal in mind, and immediately that visual is, there's a real truth in that visual Michael showed of the text clear in the center. They just have tunnel vision. And in fact, as they get stressed and have problems, that tunnel vision gets greater. And their flexibility for problem solving Another point I'll make, I'm just going to reiterate this because you brought up a great topic. How many folks are familiar with Myers-Briggs testing, personality testing? Okay, show of hands. So it's been shown that typical developers, PMs, researchers, people in our field are highly sensing individuals to the extent of about 75%. I'm sorry, intuitives. And as intuitives, we troubleshoot. We break problems down and we solve them. So when we hit a UI we can't figure out, what's going on? We step out, we open up our focus, and we look around.
And we get very systematic.
75% of the general population are sensing. And what that means is they don't troubleshoot. What they do is they look for just impressions, and they'll give up fairly quickly. And we've all encountered people who troubleshoot in our lives and people who are good at it and people who don't. So that's probably the one bias that really is true, but it's inclusive of developers, designers, or people sort of in our field, where we approach problems differently. So we may figure something out that's novel that a lot of users wouldn't. So we want to be sensitive to that. But the broader thing with the gorilla, that's just human perception. So.
Does that answer your question?
Not really.
Yeah, no, come to your question.
Yeah,
The feedback.
I got
Yeah,
nervous
sure.
that we were somehow offending developers with that suggestion.
No. What I was kind of expecting you to say was, well, given that everyone is human, and given that at any one time we may or may not see the gorilla, it's to build awareness amongst your team,
Yes.
your management, that, we're all humans.
Yes.
It's not because they're dumb, it's not because they're stupid, it's not because they don't need to be fired.
Exactly.
We need to somehow monitor or put in place procedures, which is probably what you're doing at Microsoft.
Absolutely. So, and that's the essence of that message about detection. There is structure, and there are sort of rules to be gleaned behind the science that exists. It hasn't been pulled together particularly well. So if you buy a book on UI design, and there's many to be had out there, they're typically from consultants. So you get hundreds of principles and really interesting stories, and you get impressed with how smart they are, but they don't translate that knowledge into sort of systematic application that you can put to use because they're interested in showing you how smart they are, so you'll hire them to work on your design. What we're attempting to do is structure that down so we can make sense of it. And that's the conversation. As we said before, it's the start of a conversation. You've got a thing where this may be potentially a trap. What do we do about it?
And to your point, yes, we do our best to institute things to catch things like this. And our hope is that now you can too. Rip off our stuff, please. you know what I mean? Like, go you can find videos like this. So we made our own because we can't use somebody else's. There's another one called the color changing card trick by an English psychologist. I forget his name. Wiseman, maybe?
Search on inattentional blindness.
Yeah, so you can find things like, for example, if you wanted to sensitize a whole team to something like this, saying, hey, there's a human thing going on here, and you want to kind of redo the thing we did, you can do it, you know?
Yeah, feel free to reach out to us when we give you those resources.
Yeah.
Awesome. Thank you.
Yeah.
Sure. I think you're next.
Okay.
Yeah.
So on the habituating thing, one thing we've all probably encountered a bunch of times is you get really good at using a program, and then a new version comes out and everything's different.
Yeah.
Yeah.
How important is it to,
Oh, that's a good
for
question.
habituating for, what the user is used to, but either in terms of the previous version of your program or the competitor's product you're trying to get them to move away from or things like that?
Go ahead.
You want me to go ahead? No, you go ahead.
I can take that.
Yeah, you start with that one.
Yeah,
and
no,
I'll follow.
it's an excellent question, and what you have to there's a couple of things you have to calculate. One, what is the ultimate payoff? So we're all familiar with Dvorak keyboards and the fact that there's some data that says that those actually lead to performance enhancements, and yet we still use the keyboard that we've been using for many, many decades. So the benefit has to be very clear to users. At the same time, particularly when we're dealing with UI, often change is resisted. I'm going to just give something very tactical as an example of where I think we could do better. Very often, legacy components are left in because you fear alienating a large population of users. And as a consequence, we talked about this gratuitous redundancy. Well, let's leave the old way in and put a new way in. And very soon your code gets very complicated, and the experience for the user gets very complicated. And in those cases, if you really believe the new solution is better integrated, it's better to sort of force that change on your user. On On tests that really require an enormous amount of training, like touch typing, the hurdle's really high. So you just have to ask yourself a question about what was the investment in that initial learning that you're overcoming. And if you cannot prove it, just an enormous improvement in performance, you're going to have a tough time.
And I'm going to add on to this. Is it Weber's law that's the 20% rule?
Yes.
Yeah. So Weber's law, humans don't perceive improvements of many kinds of differences between things of many kinds until the thing is about at least 20% better. So like if you've made something, and I'm being very general there, so if you've made some improvement that you can demonstrate, oh, it's 10% better, they won't know it. You know what I mean? So you've got to make a big difference. You know, a really, really big difference at times, especially for things that have been highly habituated to. Otherwise, they won't see the benefit. I mean, when the iPhone came out, it changed everything. It was radically different, too. It was radically different. I don't think we all remember that BlackBerry owned this, right? And then all of a sudden, gone, you know? They changed everything. People were habituated to the BlackBerry. It was the Crackberry, right? It was what everybody, you know, loved. Really, they did. They changed all the conventions, and it worked. Why? Because it was that much better, you know, at the time. So I think that's the question you first have to ask yourself is, do you have evidence that the thing that you're going to change to is that much better?
And what I'll add is a way to just make it really tangible. And when I talk to teams, the way I think about it is, if you don't make the change, could you get disrupted? Could somebody else come who's just going to do it and
Yeah.
then take your customers away? And if you go, there's no way they could. Like that's how you can sort of think through the problem space. But if they could, you probably want to sort of take the medicine
Better
and
think
make
about
the
it.
change.
Yeah.
Hi. So you've applied this research to the design of user interfaces and how users use the software. What about us as programmers? We have the same capabilities, limitations. What about our development process? Are you studying what we can do in the development environments to improve how we don't fall into those traps, even when we think about the software that we write, not just using the UI?
You take that
I'll
one?
take that. I have sort of two thoughts. The first is, just personally, he and I, not yet. That's a great question. That's a great point, especially on the process part, because I do believe you can apply many of these things to processes. For example, when Steve and I walk around, now we always see the gorilla too. You know, we see our traps. We see them in buildings, in building design and lots of other things. And we start to see them in processes, like you say, but it hasn't quite yet been our goal. Having said that, we do have the developer division. We have design researchers in the developer division that do work on our development products that are starting to apply this stuff. I think that's a fantastic suggestion that I've just basically heard you made. Like, why not apply it to the process, not just to the products? Am I getting that right? Yeah. Great idea. I don't think we've really started to do that yet. Thank you.
Thanks.
Yeah.
So one of the points you guys made that really stuck out to me was consistency versus foolish consistency, because that's a challenge I have with my clients. I'm a lead UX architect, and they get hooked on this consistency down to every single character. Like if you're using a colon, everything needs to be a colon everywhere. So have you found any way of making that distinction between what's good consistency and what's the foolish consistency? And how can you apply that to something?
Yeah, I can take this.
You take it.
So this is something we always deal with, particularly, I'm in office currently. So you have many, many years of invested customers who are used to how things operate. So we get into questions of familiarity. And what are those boundaries of introducing things? It speaks to the question that we had before. I'll give you my point of view on this, and I'm obviously representing Microsoft, but this is something that's not fully, we don't have the answer of just like a formula broken down. But
Wish we did.
Yeah,
I do too.
Yeah.
user is going to judge a brand, a solution, a product, coming from the same company on its ability to solve problems for them. that's going to be their highest order bit for saying, for judging what's familiar about it, because that's what they're invested in. So if you make a modification to something that limits their ability to do something important, or for example, if you, to the previous question, you change something fairly dramatically, but it allows them to do that thing they care about more, that's going to reinforce your brand, whether or not every detail looks exactly the same. Right? It's vastly more important. So the feedback I give is, that's interesting, the colon or those decisions, but we really want to be having a conversation up here about the prioritized problems we're solving for them and how well we're doing it, because you can invest an enormous amount of energy in that detail, and the fact is users won't even be sensitive to it. And we've seen this. I've been in user studies where people will attribute, you guys all know Office has colors associated with the various products, right? And they will swear that Outlook is purple, right? You know, and I know Outlook because I can recognize it because it's purple. And a lot of people will sweat this stuff out. You know what really matters, what would really damage Outlook tremendously, is if it failed to allow you to schedule a meeting as effectively as you possibly could, or to get your messages and your information. So that's my perspective. It's a lower order problem, and the way that I typically talk about it is to say, good, that's important, fit and finish is important, but let's only have that conversation when we're sure we're hitting the higher order problem.
I have one other thing to say. I've got a reference for you, because I can't quote it all. Tognazini's stuff. Bruce Tognazini, he was another one of the Mac folks. He's got a blog, and I can't remember what it is, but he talks about these levels of consistency that are most important. And one of the things that struck me about it, which I totally agree with, is some of the most important things are the super small interactive bits, common controls, for example, right? The behavior of common controls being consistent, that's kind of a very small atomic bit. Man, rock solid. Don't be messing around with the consistency of those things. That's the kind of thing to keep rock solid consistent, especially if these are global things across the system, back to variable outcomes, et cetera. And the higher order you get on some of these things, the more you can start to mess with that. So colons, really? You know, I'm sorry to hear that. You know, I don't know what the context is with that colon, but it kind of sounds maybe.
But we use this material to try to facilitate those discussions, to say, here's a real inconsistency problem. So we showed the overloaded controls. Yep. These are massively detrimental to where you have abandonment issues, and it's like, if you want to clean house on those things, and it puts the colon discussions, I think, into context. So
We hope.
hopefully, not always.
Cool, thank you.
Yep.
Yeah, I'd be interested to hear your thoughts on where the threshold lies, or I guess maybe best practices to find a threshold between, you know, allowing your users to customize your platform or customize your application, and really find a balance between, you know, establishing your brand, keeping your, you know, product as you've made it and as it is supposed to be, and then allowing users to kind of fluctuate and create their own shortcuts, or maybe potentially wreck your existing UI you spent years and years to create.
Well, it's a hard one. Do you want?
I'll give my
These are
bias.
great questions.
Yeah, these
by
are
the way.
fantastic questions. My bias is towards, with respect to our tenant framework, is apply them as strictly as possible to, or try to embody them in your defaults. But if a user chooses to make a change, if you can build in something, and it's going to be determined by the needs of your users. If you recognize that there's flexibility and there's reason for it, allowing them to do that. A lot of these traps don't apply when a user's consciously reassign something. If a user makes something invisible, and I'm going to put it off screen over here, that's a very different phenomenon. They've seen the gorilla.
They've seen the gorilla.
And they're going to be able to get to it. So that's my personal perspective on it. Do you have anything to add?
The only other thing I would say is sometimes you get into discussions about, well, but I know someone can ruin an experience for themselves, you know what I mean, if they do this thing. And at that point, you do have to make a judgment about whether or not there's enough people that will ruin it for themselves. And if there is an elegant way to allow them to customize things without, you know, ruining it for themselves. I think sooner or later, people, if you give them options to customize things will ruin your brand. You know what I mean? They just will. But funny enough, I also think now they also end up appreciating, you know, your brand if you allow them, you know, some of that customization. So I don't have a great, you know,
And we've got our forgiving tenant as well. So whatever they do, allow them to back
Yeah,
up.
we didn't talk about that. Undo.
Definitely. Thank you.
Sure, thank you.
Yes.
Finally, at the beginning of the talk, you said that there was many more traps that you could fall into. Is there a way to see
put
what
that up.
other traps or?
Yeah, we got this question before. As I mentioned, this is our first public external sharing of this, and we're working on that.
Okay.
So this is Microsoft intellectual property that we're working on making available to you. It's
And
talented.
we would like to do that, but we don't get to yet.
Okay.
Sorry.
It will not.
Yeah.
The video will be
The
posted.
video will be. The video will be. But the slide deck, no, unfortunately. For the same reason. We're working on that.
Yes.
Working on that.
So actually, as a follow-up to that question and the original question is, since you guys can't give those out, are there other resources
Yes.
that are available that you guys would
Absolutely.
recommend?
Yes.
We steal liberally. They're greater minds than ours, outside of Stephen Colbert, have done this work, and we've just tried to package it.
Right, so what would you recommend, since we can't get a hold of
I'm
your
happy to
slides?
have maybe that's a good side conversation.
That is a
I
good side
can
conversation.
give you a list of books. Give me an email address.
Yeah.
Yeah. Yes.
Yeah, it's more of an observation. One of the big problems is when you want to either remove some functionality or replace it with a different method.
Yeah.
And we have a kind of a way of asking questions in the team. First is, the backstory is that invariably, when you make a change and take out something that was just, you knew it was a kludge, and then you get feedback saying, we were using that. You know, it constantly comes back. So we ask, we have choices, and one is we make it a system setting and we leave it the way it is, and if people say, oh, you know, I wish, blah, blah, okay, go to
Right.
miscellaneous procedure. We have system settings on everything because we don't like to take anything out. Somebody's going to come back. The other one is if we have a better way, sometimes we introduce it as a choice, and we like to throw in, when that choice is there, why they would want to use it, maybe a sentence at most,
Right.
and then we recommend, because the worst thing is they get to a choice, and I never saw that choice, now they have to call us up, we don't like, so there's a lot of managing the pathways.
I think that's a great contribution to the question that was asked before about making those changes and managing expectations for users through that process. You can do it through advertising, where you show somebody doing it the new way, right? If you're like a mass consumer market, or you can offer some sort of explanation for users. I think that's a great
And a
contribution.
recommendation, because you don't want them to have to stop.
Yeah.
Yeah.
Okay.
If that's it, please
Any-
give us some feedback. We'd love to hear it. Especially, you know, open-ended comments. Those always help us even more. Like the one that, you know, I misspelled something. That was a good one. Yeah. Unfortunately, I figured I'd do that.
Throw down later.
Yeah.
You have another question? Or you just
Oh,
wanted-
oh, yeah, you like that one too? Yeah, so we handed in our deck, and obviously we didn't use the template, you know, because we used our own little style here, and clearly it reformatted things for us. Awesome. For the whole world to see. Thank
Thanks,
you.
folks.
Thank you for sticking around.